Okay, so under the general class information module, which actually let me go to student view because yours looks a little different. At the bottom, there's something that says PSAT prep, and then there's an assignment with today's date. So there's extra resources that we're not going to get to today, but the resources that y'all want you to open for today are the first two that say review sheet and SAT prep. And then the third one where next to the yellow where it says PSAT Fall 2022 practice test. So the review sheet is exactly that, okay? It has a lot of the content that you need to know for SAT, and it has some for ACT. I want you to just like send it to Notability. Let's see if I can actually open it here. But this one, and again, we'll come back to it, but this one is basically something that was just like a brief of a lot of topics that some are fresh, which is great news, and some it's been a little while since you've seen them. So you definitely want to review. Some of them are from geometry, okay? And then the second one is the SAT prep sheet. So one says PSAT, one says SAT. I just open the same one. Which has some overlap, but then there's some additional stuff on there, which is why I want you to download both. Okay, that one looks like this. It has some additional topics. And then the third thing is that practice test. So this, if you got your packet, like your booklet, this thing, from guidance, like this is actually is what's in here. But there are two tests in here, a non-calculator one, and that's test 3, and then there's a calculator one, which is test 4, that's 45 minutes. We're today going to do together the non-calculator one, the 25-minute one. Like I'm going to set a timer. You're going to feel that experience. You're going to see a clock. Like the idea is for you to kind of get that environment started to feel comfortable. And then if you are serious about, like, especially if like you're a junior and you're serious about your score, my recommendation would be to go home sometime between now, because you won't have homework for me, to go home sometime between now and Wednesday and take that 45-minute practice. Sit in a room, set a timer, give yourself no notes, just that practice, okay? So if it's in Notability, obviously it's a little different than it's going to be on taking paper. If you have this, and they have plenty of them in guidance if you didn't get one, there's actually a physical book in here, okay, that has that exact test, and my recommendation would be to take it. Sometimes types of questions repeat, and you're going to be like, oh, I saw something like this, just like a practice test for a regular chapter test. Sometimes it's the comfortability level. Like I know I'm comfortable bubbling. I'm comfortable. This is all the scrap paper I get. So I can't have like 2 pieces of scrap paper go back and forth. This is what I get. So it's a little bit about that. It's a little bit about the timing constraint. Like all those things you want to get comfortable with. So I wouldn't do it. I would literally do it in an environment in which you can stop for 45 minutes and set yourself a timer. Don't like go and come back to it. Go and look at notes. Don't do any of that stuff. Try to take it as though you were actually taking a test. For me personally, like I know it was, talking about 100 years ago, but for me personally, I took the SAT twice, and the only thing I did different in between was take practice tests, and my score jumped like 160 points just because I got more comfortable with the types of questions and with that kind of time constraint environment. So sometimes that's all you need, okay? It might just be this one exposure today that makes you feel a little bit more comfortable the next week, which is why we're doing it. For the calculator portion, you can pretty much use any calculator that you guys have purchased. So you can use a graphing utility, and I would strongly recommend it if you're comfortable with it. If you're a junior and we're going to do more practice with this calculator throughout the school year, and you want to start thinking about when am I taking the actual SAT, I would strongly recommend like the June test. 1, you don't have regular school going on, so you don't have that stress happening. 2, we'll have gotten into some more stuff. Like as we move through the year, you're going to get into things like series and sequences and that kind of stuff. And 3, we're going to start using our graphing utility a lot this year when we get into that graphing section, and you'll get a lot more comfortable with the capabilities of your graphing calculator, okay? If we're not there yet, then a scientific calculator totally is fine, okay? And it can be done without it. It just certainly makes it a lot easier to do it with it. But it's like the requirements on, and you'll see them, like ones that store documents you cannot use, and ones that literally are like an accounting one where you type and like it prints, those you can't use. But pretty much anything other than that you can use. And that's in this book, and they posted it on AMHS Student, the acceptable calculator. So if you have a question about it, feel free to look, okay? All right, so this is that first one. It says PSAT review. A couple of things just in the beginning that you like seem like basic skills, and yet if you don't understand the wording on it, could get a whole question wrong. The difference between an integer and a whole number. So an integer has positive and negative whole numbers. Okay, it includes 0 and positive and negatives, but still whole numbers. Whole numbers start at 0. If it said something like a natural number or a counting number, how do you start to count? What number would you use first? 1. So natural or counting numbers start with 1. They do not include 0. Okay, if you think about it, like obviously if I was counting the kids in the room, I wouldn't start with 0. I would start with 1. Prime numbers, and one of the biggest mistakes is that people include 1 as a prime number. 1 is not a prime number. Prime numbers are any number that's only factors are itself and 1, but it starts with 3. So 3 is your first prime number. I'm sorry, 2. 2 is your first prime number. Okay, 2 is the only even prime number. But then you've got things like 3, 5, 7, 11, 13, 17's not in there, but 17 should be in there. Those are prime numbers. A rational number is any number that can be written as a fraction. So this is either a whole number, because that you could put over 1 and it would still be written as a fraction. This is a fraction like something 2/3, 3/4, whatever it is. Even if it's improper, it's still rational. And it would be anything that's a decimal that terminates or repeats. So something like 0.5 is a rational number. Something like 0.3333 or 0.6666, those are repeating numbers, and those are also rational numbers, right? Because that could be written as 1/3 or 2/3. The things that are not rational numbers are like the square roots of not perfect squares. So square root 3, square root 5. If you hit that on a calculator, you would see that number go on to the end of the calculator and it doesn't repeat. Pi is an irrational number, 3.14. If you've ever heard those really smart kids that like have all those digits of pi, it never ends, right? So that is one of the things that's also irrational. Something that cannot be written as a fraction. Oh, there's the natural numbers. I knew it was on there somewhere. Okay, then you get into some geometry stuff. So you want to remember things like your 30, 60, 90 triangles, your 45, 45, 90 triangles you talked about in geometry. Those are actually on the little box that's given to you for the PSAT and the SAT. They're not on the ACT, but that box you'll see when you get to practice test. There's a little box of skills. But so 30, 60, 90, 45, 45, 90 are on there. But it won't be a straight up question like that. It will be an application of it, like something like this, where it gives you a cube and then it's talking about the side of a cube with a diagonal. So a cube would have all the sides the same, which would be a 45, 45, 90 triangle when you give it a diagonal. That kind of stuff might come up. Like an equilateral triangle with an altitude would be a 30, 60, 90 triangle. So they'll do stuff like that. Pythagorean Theorem, a squared plus b squared equals c squared, is a really likely thing to see. When you get to function notation, so this is like f of x, okay? Hopefully we saw a little bit of this in Algebra 1, but it's been a while. That really just means the f of x is the same thing as y. So if I saw something like f of, and they'll write it like this, f of 2 equals 3. What's inside your parentheses is the x coordinate, and then f of whatever is the y coordinate. So really all this is a coordinate point that is 2, 3, and it will disguise it in function format, which is super confusing. So think about it being f of x, whatever's inside the parentheses would be the x, and then what it equals, whatever f of x is your y. So they can give you a point like that. So like, let's just say they asked you, like here, they're trying to say, well, it would start with f of 2. What is f of 2? And then they give you a chart. You're going to where the x, because that's the 2, where the x is 2, so if it's that one, then my answer is actually 8, okay? Functions are one of the things we're going to get to this year that we haven't yet. So that's another reason why I would say if you're a junior, plan for end of the year. Okay? If you're a sophomore or freshman, great, because you're going to get function exposure before you even have to take your standardized SAT. So like this basically says this would be a 2, 8. This would be an 8, 100. That would be coordinate point disguised in function format. If you see something where you get an equation for f of x and then it says find f of 2, it just means take the 2 and plug it in for all the x's that are there. So it's just function notation. You're plugging in. Whatever's inside the parentheses goes in for x. Some more function notation at the top. So if it says f of 0 equals -1, that is a coordinate point 0, -1. The second one you would need the chart. So we won't do that one yet. We did exponents. So like all of these exponents are rules that should be fresh in your mind. When you're multiplying, you add the exponents. If you're expanding and you raise it to a power, you must FOIL. You can't distribute, okay? When you're raising a power to a power, you multiply those exponents. Anything raised to the 0 power is 1. A negative exponent moves it to the bottom, and then a fractional exponent turns into a radical. All those things were in Chapter P, so hopefully that's still relatively familiar. Some more geometry. So the triangle inequality theorem says any two sides has to be greater than the third, which means any two sides, if I add these, that has to be greater than x. And if it gives you two side lengths and it asks you what could the third one be, it's got to be bigger than the sum, but less than the, bigger than the difference, but less than the sum. So difference, sum. So the difference between 4 and 3 is 1. The sum would be 4 plus 3, which would be 7. So x has to fall in between those two for that missing third side. The second one is the remote triangle theorem, or the exterior angle theorem, I think is what the current book calls it, which says that an exterior angle is equal to the sum of the two remote, which means non-adjacent, interior angles. So x here would equal the sum of those other two angles. Here's our special right triangles. This is what's given in that box, the 30, 60, 90, and the 45, 45, 90s. And then 45, 45 often shows up in a square with a diagonal, and 30, 60, 90 shows up in an equilateral triangle with an altitude. Isosceles triangle properties, opposite the angles, two angles are congruent, and the sides opposite those angles are congruent, and vice versa. Two sides are congruent, the angles opposite them are also congruent. Parallel lines, you want to look for things like corresponding angles, alternate interior angles, alternate exterior angles, same side interior. Do you remember that? They're learning that now, so we're going, like your brain just went back 365 days if you remember it. Good job. Okay. Vertical angles, which are the ones that make the x, those are always congruent, and linear pair or two angles that make a straight line would always add up to 180. Similar triangles show up a lot on standardized tests, and these are like mini-me triangles, two triangles in which they have the proportional sides. All the angles are going to be congruent, but the sides are be proportional. So like a little model figure of something else. If it's the proportion, the ratio is like 1 to 2 or 2 to 1, then you would do that with the side lengths. These areas are on the PSAT and the SAT box, okay? So those I wouldn't worry about remembering. They're not on ACT, but they are on SAT, but just know how to use them. Triangle, rhombus, trapezoid, circle, and circumference. Is trapezoid? Hang on. I don't think trapezoid's on there. No. Circle, rectangle, triangle, and then volumes. So this one, rhombus is not on there, and trapezoid is not on there. The area of a shaded region, so if you're looking at like a circle and it's asking for the area of like a piece of the pie, then you do 360. So if it's a circle and it gives you a little chunk like this and it wants the area of that little piece of pie, I would do the measure of the arc, which is this arc, same as that central angle, over 360 times pi r squared, which is what this is. If you're looking for the arc length, meaning just the length of what's on the outside, like the crust of the pie, it's the measure of the arc over 360 times 2 pi r, which is the circumference. So you're finding a portion of the circumference or a portion of the area. Properties of parallel lines: opposite sides and angles are congruent, diagonals bisect each other. A rhombus has diagonals that are perpendicular. The sum of the interior angles of a polygon is n minus 2 times 180, where n is the number of sides. And the sum of the exterior angles is always 360 degrees, no matter how many sides the polygon has. Sophia. This is the area of the shaded region, almost like the crust, the piece of a pie. And this is the arc length. You're welcome. Hopefully this section is a lot of review that we remember. These are slopes of lines, right? So you did this in algebra, you did this in geometry. Okay, you've got positive slope, negative slope, zero slope, undefined slope. 2 formulas to find the equation of a line, y equals mx plus b, or point slope, which is y minus y1 equals m times x minus x1. For an x-intercept, we find where y is 0. For a y-intercept, we find where x is 0. To find slope given 2 points, it's y2 minus y1 over x2 minus x1. And then the midpoints, add the 2 x's, divide by 2, add the 2 y's, divide by 2. Distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. Parallel lines have the same slope. Perpendicular lines have the opposite reciprocal or negative reciprocal. And sometimes it will ask you, like, you'll get a graph and you're talking about your intercept. So remember, the x-intercept would be where it crosses the x-intercept. The y-intercept would be where it crosses the y-axis. Parabolas are something that we haven't gotten to yet this year. Okay, if you've done them before, then vertex is negative b over 2a. If that means nothing to you right now, don't stress out about it. We will get there. X-intercepts, you would still set y equal to 0. And then transformations of graphs we haven't gotten to yet this year. But a shift, if you're adding and subtracting, it shifts it up or down in between the parentheses, right and left. Absolute value, if you're in absolute value and it's equal to a number, you're going to set it equal to the plus and minus of that number. And then if it's an inequality and it's a less than, it becomes an and statement. Again, we haven't gotten to it yet this year. So if you're like, I don't even know what she's talking about right now, that's okay. You get to that question, you take an educated guess. And probability in general is something that you're looking for out of the whole amount of something. So if it's pulling a rock out of a box, if it's pulling a sock out of a drawer, specific color, you want to figure out however many you want to get, that like a color of a specific color over the total amount. And I would say we haven't gotten to any of that stuff, so don't stress about it too much. Percent of change is the change over the original mean, and there's always a question on mean, median, or mode. The mean is the average, the median is the middle, and the mode is the most often. So most often starts with M and O, which so does mode, if that helps you remember. And the median, like if you're driving down the road and there's the median in the road, it's the middle of the road, okay? And then the average, you would add them all up and divide by 2. Divide by the number of whatever it is. All right, the second one has a lot of the same stuff. I think the only thing that's different, all that first page is the same. The only thing that's on here would be the prime factorization that's not on the first one. Okay, and obviously that's your factor tree. So if you get your square roots and you want to break it down into the product of its primes, that's what that means. All right, I am going to, which you're going to get a little bit less than 25 minutes, but you'll go till the end of the card. I'm going to shut up. I'm going to let you work, okay? I'm going to literally set a timer like you would normally be in an environment in which there has a timer. I want you to work on math tests without the calculator, okay? So you want to open it in Notability. And you work and use some of the strategies. Like if you get to a question, you have no idea what it is, skip it. Go to the next one, okay? Find the easy ones because sometimes they start easy and then they eventually get hard, but sometimes they go out of order. So do your